Hi, this is Lori, and welcome to my series on the Pico W. This is episode 2 in a 3-part series where we're going to build a digital Etch-A-Sketch. In this episode, we're going to learn how to use potentiometers, and they will be the dials, the drawing dials, for our Etch-A-Sketch. Let's get started. Let's talk about potentiometers. Potentiometers are a variable resistor, and we adjust the resistance by moving a slider or a rotating knob. It has 3 legs: power, a signal, and a ground. We adjust this resistance by turning the knob, and it moves inside an internal wiper. You can see in this diagram over here of a panel potentiometer, you can see the wiper here, and as we turn the knob, it moves the wiper around, and it's touching something like a resistive element like carbon, and it adjusts the resistance based on that wiper. Now they can be scaled either linearly or logarithmically. You'll have to see when you purchase one, you'll see that that's one of the things that will be described about the potentiometer. So as we move it through the wiper, through the rotation, the resistance applied to the voltage pin is based on that linear or logarithmic scale, and it also will divide the voltage of our circuit between ground, being 0 volts, all the way up to whatever the input voltage is to the potentiometer. So I have a couple pictures here of 2 different kinds of potentiometers people typically have for beginning electronics. This one here is a panel potentiometer, and then this blue kind is often found in a lot of electronics kits, and it's sometimes called a trim pot because it's a little harder. They're pretty small, and it's a little harder to adjust them than the panel knobs. The panel knobs are used for like volume control, that sort of thing. So for this project, I've decided to use some panel potentiometers, and you'll see a little bit about why coming up. Here's a diagram of the circuit we're going to use in this episode. We have our OLED display hooked up as we did in episode 1, part 1 of this series, and now we're going to add in our potentiometers. So I have 2 of them here. These are the diagram of those little blue ones, but the panel ones will be similarly hooked up, and you'll see that when I show the real circuit. And for the potentiometer, we're now going to create an analog signal, and we need to read that with our Pico. So we're now going to use the analog to digital converter in our Pico, and we're going to need to hook it up to those specific pins. And you'll see here on the pinout that we have 3 pins that we can use to connect up analog signal devices such as potentiometers, and we're going to use these 2 right here to connect up our potentiometer. So here we go. There's the 2 of them because we're going to have the 2 potentiometers to do the drawing with our Etch-A-Sketch, so we'll need 2 of them. And I labeled them green and blue, and you'll see that's because that's how they're colored. The knobs are colored on the ones that I have. And this one will control the X position as we draw on our screen, and this one's going to control the Y position as we draw on the screen. So the up and down for the Y and the left to right for the X. So that's how we're going to move our little dot around as we draw using our dials, our potentiometers. And we have them hooked up here back to those analog to digital converter pins that we saw on the pinout. And then they're also connected to ground and power, each of them. I decided to use those panel potentiometers that we have a picture of right here, and I decided that because they're pretty sturdy. They're a little easier to turn once you put a knob on them, and I also was able to modify them so they would sit pretty firmly on the breadboard as we're prototyping this Etch-A-Sketch. So I took a few pictures, and you can see that there's actually some holes here in the ones that I have, and I was able to take some header pins and solder them on so that I could put it right onto the breadboard using those header pins, and it sits relatively firmly on that. So that was the reason for choosing that particular one, but you can certainly use the blue ones that people typically have from from their beginning electronics kits to do this project. Now let's take a look at the actual circuit. So you can see we have the display that we hooked up in part 1 of this series. And now we've added our 2 potentiometers, the panel potentiometers, and they're connected back to the analog to digital converter pins on our Pico. I'll just pull them out just to show again how I modified these to have some header pins onto this so that it would sit flat. But if you don't have them on here, people use these pins right here and they plug it in. I'll just put it like this, sideways, like that, and then they can turn the knobs kind of sideways. And I just always found that a little hard to do, so I wanted to find a way to get it to sit flat. Let's write our first piece of code to read the value from the potentiometer. So as we turn the knob on our potentiometer, we're going to change the resistance, and we want to read the value that it's going to get back to us. And we'll import our needed libraries, and we're going to set up the pins for these 2 potentiometers, the blue and the green one, and we'll connect them to the analog to digital converter on pin 26 and the other one on pin 27. Then in our while true loop, we'll read the value from each of the potentiometers using the read underscore U16 function. Then we'll print both of those out to the screen, sleep for a second, and keep reading both potentiometers every second. Let's go ahead and run that and see what happens. And you can see here we're starting to get some values from our potentiometer. They're in the low hundreds. Usually somewhere around 400 or 500, but you can see it varies a little bit. There's some noise in these potentiometers, and that's going to figure into our project as well. I'm going to go ahead and turn the green knob so you can see they're all the way to the left, both of them. And if I turn the knob on the green one up, you can start to see the green knob, the green values increase. Now we're up into the 22,000 or so. It's going up, turning the knob a little bit more, a little bit more. Now I've got it all the way over to the right. And you can see we're getting a value somewhere around 65,535. Let's try turning the blue one up slowly and see what happens to that one. And you can see a similar increase. Get all the way over to the right with it, and it's also up to 65,500 and something. So they read somewhere between 0 and a little over 65,000, and so that's the scale that we're reading those potentiometers at. Now we're going to need to use that scale and convert it to something useful for us as we want to do drawing on this screen here. So that'll be kind of our next goal, is to try to figure out how we can take the value we're getting from this and get it to a value that we can use on our display. The next program we're going to use to find out what a good value for the low end of the range for our potentiometers is, and what's a good value for the high range. And you can see from the previous program that we ran that it does bounce around a little bit. So I wrote a program to kind of calibrate these potentiometers. In this program, we'll import our modules that we need. We'll set up the pins again, just like we did before. In this case, I wrote a little function so that we could get an average value for the potentiometer. So this function will read a certain number of times, n will be how many times we want to put into our average, and then pot name is just the name for the potentiometer when we set up the pin. And we'll start off with a sum, so we're just going to kind of sum up the number of readings we want, and then we'll divide by the number of readings to get the average. So this for loop here does just that. It reads the pin, the potentiometer, and adds that to the sum, sleeps for half a second. So it's going to take a little time to go through this a few times because we want to get a good average. So we want a little time to go by between each reading. So that's where I put a little bit of sleep in there. and then we'll calculate the average and return that. So that's what we're going to return out of this function. And then to go ahead and do the calibration, we're going to start off by telling the user to turn the potentiometers all the way to the left so that we can get the low average value. And I'm going to run our new function 10 times for both the green and blue, and then we'll print that to the screen. Then it's going to ask us to turn them all the way to the right so we can get the high value for the potentiometers, and we'll again use our function 10 times to get our average, and we'll print that to the screen. Let's go ahead and run this. Okay, it says to make sure they're all the way to the left, so I have them to the left, but let me just double check, make sure they're in there good, and then we just need to press enter. So press enter. It's going to take a little bit of time because it's going to go through 10 times, and then it should return those two low averages to the screen. Okay, now we can see them. So about 417, 419, very close to each other. Let's turn them all the way to the right as it's asking us to do. There we go. Got them all the way to the right, and we'll go and press enter again, and now we're going to get the high average. Take just a little bit of time here, a few seconds, and we should get that back. There they are. All right, so this gives us a good number to use when we start to do that conversion from the scale that the potentiometer gives back to us to the display that we have, which is 128 by 64. So to do this conversion from the scale of our potentiometers to being able to move around on our OLED screen, which is 128 by 64, we need to do some math to figure out how we can make that scaling change. And we're going to use two basic algebra concepts where we're going to use the slope of a line and the point slope equation of the line. And here's the thinking we're going to use. So when we did our calibration program, we saw that roughly both potentiometers read around 400 on the low end and went up to the max of 65, 535 roughly on the high end. So we have those two kind of points. So we know that we go from 400 to 65,000 on the potentiometer, and when we're going to want to move around on our screen, we want to go from 0 to 127 when we're going in the X direction, and we'll want to go from 0 to 63 in the Y direction. So if we do the math, take the slope, and use these 2 points, these X min, Y min, X max, Y max, and we put these into the equations and solve for it, we can, for example, find that the X position will be given to us by this equation using our 2 points. And so we can take our potentiometer reading and input that, and that's going to give us an X position between 0 and 127. Let's see that run in our program. Let's put our newfound algebra and our calibration numbers to use. Here's the results that we got from the Calibrate program for our green and blue potentiometers for the low end and for the high end. We're going to import our modules, set up our pins, and then created a function called scale that will take in the value from the potentiometer, and we can give it the X min and X max and Y min and Y max. So we're scaling from X to Y with this function using those equations that we saw previously, and we're going to get our scaled value and return it. So in the while true loop, we'll read the potentiometers, and then we'll work first on the X position from the green potentiometer. And remember, when we did the calibrate, we got about 418 on the low end and 65,517 on the high. And then we want to convert it to the range for the X position, which we could go from 0 to 127 pixels. Let's give ourselves a border. So we'll only go from 4 to 123, just so we don't slip over the border because of noise in our potentiometer. We'll do the same thing for the Y position. We'll use our scale function here, and we'll use the numbers we got from Calibrate for that one. And in this case, the Y position goes from 0 to 63. So we'll give ourselves also a little border here. We'll go from 3 to 61. All right, let's run this. And I'm going to put it on the low end first here. Turn them all the way to the left. And let's run it. There we go. So we're seeing our low end. And we're getting the 4 and 3. So you see sometimes because of noise we bounce down a little bit, but that looks to be doing pretty well. Let's put it in the middle here. It's roughly the middle. And yep, we can see that that's roughly the middle of our pixel ranges. We'll go all the way to the high end. Turn this one up too. And we wanted to go to 123.61 on the high end, and you can see, yep, we're pretty close to that most of the time. So our scale function works. Believe it or not, we're actually ready to do our first version of the EtchASketch program. So we have all the needed pieces now. We're going to import the proper modules and set up the OLED like we did in part 1. And next, set up our potentiometers. We'll need our scale function that we used previously, and we'll go into our while true loop. We'll read our potentiometers, and we'll rescale them to the X position and the Y position. Then we're going to use the pixel method that we learned in part 1 of this series to draw a pixel. We're going to turn on a pixel at the X and Y position, show it. We're going to sleep just a little bit, and it'll keep going around and around. So as we move our potentiometers, we're going to be turning on this pixel as we move it around, and hopefully it'll leave a little trail behind it because we're not erasing it, and we should have something that looks a little bit like an Etch-A-Sketch. All right, and then we'll also have our try and accept so that we can gracefully leave our program. We'll clear the OLED and show that so that it gets cleared when we stop the program using Control-C. Let's give this a go. Very excited. All right, it says it's running, and you might see that I have this set to the far right, and you may just be able to see that little pixel there. So I'm going to turn the blue one a little bit and move it across to the other side. And let's turn the green one up some. And let's turn the blue one around. And I'll turn the green one down a little bit. And we'll go this way. Hey, this is working pretty good. Wow, we have a digital Etch-A-Sketch. Now, in episode 3, part 3, we're going to improve this a little because you might notice that it looks a little fuzzy. The line isn't real sharp, and that's because of some of the noise in our potentiometer in our circuit. So there's some ways that maybe we can take a little noise out. And we're also probably going to add some graphics to the start of this so it looks a little more polished. And we'll add a button so that we can clear this screen rather than having to go Control-C to end the program and clear the screen. So we can draw just like you would with an Etch-A-Sketch, but you used to put it upside down and shake it. So our button will be kind of what you do there to clear out the screen to start a new drawing. That's what we're going for in part 3 of this series. Thanks for joining me.